Let's look at vector algebra. 20. Suppose the angle between a vector b and the y-axis, okay, vector b, and the y-axis of a rectangular coordinate system is theta. There's your y-axis. There's your vector b, and there's the x-axis, and there's your theta. Okay, suppose that this angle is theta. Write an expression for bx in terms of the magnitudes of b and theta. Let's redo this here. You got y, you got x, there's your b vector, there's your angle. So remember, what colors can we use? Use green. Remember, there is your by vector. It's the y component of this guy. And remember, that is your bx vector. You can also write that, draw that there, right? There is bx. And remember, this b vector is made up of two components, one in the x, one in the y, or one in the y, one in the x, and it looks like this: bx plus by, right? But now, how do we write these in terms of theta? Okay, so we know bx is the opposite, right? So this is going to be the magnitude of b, times, because it's the opposite of that, it has to be the opposite of that angle, the opposite, so it's sine theta. And actually, we also need to include our I vector there, because this is going in the x direction. Remember, this is just the magnitude, and this is your direction. Okay, plus b, the magnitude of that vector, cos theta j. Okay, so remember, this is the magnitude of that vector, but we also need its direction, and j is the, remember, I and j are unit vectors. Remember, all they do is they give a certain magnitude, a scalar value. They give it a direction. Okay, so for me to say, say now the magnitude of b was 10, and I said 10 sine 45, for example. All that's giving me is a number. It's all it's giving me is a scalar value. It's not telling me anything about direction. So this is another thing which is very important. To say this, b is equal to b sine theta plus b cos theta is completely wrong. Completely wrong, because all you're doing is you're adding up two scalar values and you're giving a final number. There's no direction information. So you have to include these guys, okay? Alright. Okay, so I think we got that under whatever. And 21, actually, how are the component vectors ax and ay are vector a, and if you read through this, I've basically covered it right here as well. Okay? Alright, let's look at the next one. Projectile motion in 2 dimensions. Actually, let's stop there. See you in the next one.